Alright, so here we have a scientific notation question. They want to know what is this number, which is already in scientific notation, and they want to know what is it in standard form. So scientific notation, of course, means the first number is a number where the absolute value of that number is between 1 and 10. Now it can equal 1, so let's say this number is a. Let me just write this in notation for you. This number a, the first number, the coefficient, some people call it the first factor because we're multiplying these two factors here. This first factor is greater than or equal to 1, but at the same time less than 10, and we're talking strictly about the absolute value. So for example, let's give some examples of a and say if it can equal that or not. So a could be the number 1 or negative 1. So you write plus or minus, that means positive or negative 1. It could be plus or minus 9.9. It cannot be, right, plus or minus 10. That's not acceptable because that would be redundant. We are multiplying by powers of 10. We can get into that later. And it cannot be plus or minus a decimal or fraction like 0.9, right, or 0.1. So these two are not acceptable, but these two are. So anything that's a positive or negative that's greater than or equal to 1 but less than 10 is fine. And the second number will always be 10 to some power. Let's call it power b, and b can be any power. So it's actually quite nice, when you have it written in scientific notation, to write this in standard form is quite easy. If it's a positive exponent, that will make your number larger, right? Excuse me, it'll move your decimal to the right. Not always larger, because if your first number is negative, as you move the decimal to the right, you're getting a number that's even more negative. So I'll show you in this example. So 10 to the 10th means take 3.98 and multiply it by 10 10 times, 10 to the 10th. And every time you multiply a number by 10, your decimal goes to the right. So here I'm moving twice, right? So I'm starting here, 1 hop past this digit, 2 hops, and then how many more hops? Well, 8 more to end up here. And that means there'll be 6, 3, 4, 5, 6 zeros. Did I do that right? No, I did something wrong. Sorry. There will not be 6 zeros. If there are 2 hops here and 8 more hops, there will be 8 zeros. Sorry about that. And I split it up like that to make it easier for myself, because the 2 and the 8, I always think, well, if I'm hopping 10 times, how many hops are taken by the digits I'm given, in this case 9 and 8, and how many more are left? So that's our number, and you'd write it out without the arrows, of course. 6, 7, 8, and I work backwards. Every 3 digits I put a comma. 3, 6, 3, 6, 7, 8. Oh boy, making mistakes everywhere. Okay, so that's our number. Ignore this comma here; it should be moved over. Sorry about that. So we have 8. This is 800 million, 9 billion, 39 billion, and that's it. Now I was saying if this first number was negative, you can imagine this number right here would in fact be negative 39 billion, which is a very, 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 very low number. And so with negative numbers, the more zeros you add, the more negative it does get. Now if this was a negative exponent, let's say it was 3.98 times 10 to the negative 10th. The only difference there is when you have a negative 10 as a power, that means divide this number by 10, not multiply it. It's a negative exponent. You divide by 10 that many times. And when you divide by 10, you just move your decimal to the left. So here, your decimal starts here. We have 1 digit and then 9 more to go. So here we'll have 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros in total. So that negative exponent does refer to division. Alright, hope this helped.